Hi everyone, welcome to
amazing channel of Brilliant Katha.
When you're rubbing one body with another body, electrons are transferred from one object to what? Another object. Okay, this process, this type of electricity is been given a name.
halogen connected carbon sp3, then it's connected to benzene. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3, see then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartilage fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.
Brilliant Katha.
Hello dear students, good evening. Welcome to the live Master NEET DPP program. Today we discuss the chapter laws of motion. Okay, questions. First one, a body of mass 10 kilogram is acted upon by two forces, each of magnitude 10 Newton, making an angle of 60 degree with each other. Okay, find the net acceleration of the body. Clear? Here a body of mass 10 kilogram is under the action of two forces which are equal in magnitude 10 Newton but directed at an angle of 60 degree. Okay, consider a block whose mass is 10 kilogram. It is under the action of two forces. This is 10 Newton force and let this be also 10 Newton force, and the angle here is 60 degree. Right? Question is, find the net acceleration of the body. What is the net acceleration of the body? The net acceleration of the body, A net is equal to total force divided by mass. Net force by mass. Okay. Here the net force is equal to root of the magnitude of these two forces. Very simple question. 10 square plus 10 square plus 2 into 10 into 10 into cos 60. Okay, the magnitude of two vectors, addition of two vectors. Okay, this is 100 plus 100 plus cos 60 is 1 by 2. 10 into 10 again 100. Isn't it? 300, root of 300. 100 into 3. Root of 100 is 10. It is 10 root 3. Okay, 10 root 3 is the net force. 10 root 3 divided by mass of the block is again 10. So answer is root 3 meter per second square. Okay, root 3 meter per second square, it is 1.73 meter per second square. Very simple question. Okay, moving to the next. A force time graph for a linear motion of a body is shown in the figure. The graph is between force and time. The change in linear momentum between 0 and 7 seconds is 0 second is here and 7 second is here. What is the change in linear momentum is asked. You know, the equation of force from Newton's second law is dp by dt. Okay, then what is dp is equal to f dt. dp is equal to f dt. Okay, then integral dp is equal to integral f dt. Clear? Integral dp is what? Integral dp is the change in linear momentum. And what is integral f dt is the area under force time graph. Area under force time graph. Okay. What is the total area under the graph? This portion is, see, this portion is of negative area. This portion is of negative area. So this is equal to, this area is half into BH. Okay, this one is, base is 1 and the height is -1. clear, plus this area. What about this area? Is length into breadth. Length is 2, breadth is also 2, that is 4, plus this area is again half into base value is 2 and height value is minus 2. Okay, 2 into minus 2. Okay, plus this area is length into breadth, that is 1 into 1. Okay, that is 1, plus what about this area is half BH, half into what, this base is 1 and this height is minus 1. Okay, 1 into minus 1. Okay, this is that. This is minus half, this is minus half, and this is 1, so these two are getting cancelled. Minus half, 1 cancelled. 4 minus 2. Okay, 4 minus 2 is 2 is the answer. This is equal to 2, and the unit of delta P is Newton second. 2 Newton second is the answer. It is option 1. Clear? Very simple. The next one is, in the figure shown, M1 is 10 kilogram. This mass is given in the question as 10 kilogram. M2 is 6 kilogram. This is 6. And M3 is 4 kilogram. Okay, fine. And T2 is equal to, what is T2 is equal to asked, and T3 is given here 40 Newton. This is 40 Newton, right? T2 is asked. What is this force is asked? Okay, actually this force is responsible for the acceleration of these two blocks. Clear? So we can write that T2 is equal to MA, total mass into acceleration. This force is accelerating these two blocks together. So the total mass here, it is M1 plus M2 in the case of T2. M1 plus M2, okay, into acceleration of the system. Clear? M1 plus M2 is 10 plus 6, that is 16. Okay, now what is the acceleration of the entire system? The acceleration is due to this net external force 40. Okay, so that acceleration is the force divided by total mass. What is the total mass? 10 plus 6 plus 4, that is 20. So this is the total mass. Okay, so this one is the acceleration of the entire system, and mass of these two blocks, that value will be equal to T2. Okay, so this is 40 by 2, that is 40 by 20, that is 2. 2 into 16, that is 32. Isn't it? 32 Newton is the tension acting in the string. Okay, what about the tension in the string? In this string, it is M1 into acceleration. M1 is 10 and acceleration is here 2. So 10 into 2, 20. Okay, here this is 20 Newton, here it is 32 Newton acting totally. Okay, that's it. So the answer of this particular question is 32 Newton. They are asking the T2. This tension asking, so it is 32 Newton. Okay, very easy. The next one is a block B is pushed momentarily along a horizontal surface with an initial velocity v. This is pushed with an initial velocity v. Okay. If mu is the coefficient of sliding friction between B and the surface, here there is friction coefficient mu, clear, then block B will come to rest after a time t. After what time this block B comes to rest? Okay. Initially it is pushed with a velocity v. Okay, soon after this pushing, it is experiencing retardation due to friction. Clear? Retardation force will be in this direction. Retardation force will be in this direction. Okay, this retardation force actually mu into mg. This is the retardation force. Okay, so what is this retardation value is equal to retardation force by mass. Mu into mg by mass, that is mu g. This is the retardation force. Okay, now we have studied the equation of stopping distance. Okay. What is the stopping distance? Stopping distance is equal to initial speed divided by the value of retardation. S is equal to U by A, isn't it? Here, what is the initial speed is? It is V given in the question, and the retardation is mu G. Retardation value mu G. Okay. V divided by mu G. V divided by mu G is option 1. Okay. Very simple. The case of stopping distance. Okay. The next one is, two blocks of masses M and M are connected by a string passing over a pulley as shown in the figure, right? The downward acceleration of the block with mass M is, what is the downward acceleration? See, if this block M accelerating downward, this block is accelerating forward in this way. It is also having acceleration A. Okay. Now, what is this A is asked in the question? See here we can draw the free body diagram, otherwise we can apply the Newton's second law here. The net force acting on it is MA. See, mg force is acting downward and tension acting upward, and what is the net force there is mg minus t. This is equal to mass of the body into acceleration. Okay, this is one equation. And when we observe here, what are the forces here? In this way it is acting, tension T is there, same tension in the same string, same tension acts. Okay, so what is this tension here? According to this mass is tension is equal to ma. This tension is equal to ma. Tension is equal to capital M into A. Okay, now this first equation becomes mg minus ma is equal to ma. Clear? Which means mg is equal to m plus m into acceleration. That is, acceleration is mg divided by m plus m. Okay, very direct, simple question. Okay, this type of questions are asking in NEET examinations. It is directly concept based questions. Okay, you can easily go through this question within or under a minute. Okay, by the proper application of concepts. Here we applied the concept of Newton's second law and solved it within steps, right? Okay, next one is, a horizontal force of 10 Newton is necessary to just hold a block stationary against a wall. The coefficient of friction between the block and the wall is 0.2. Here, consider a wall and a block is pressed against this wall by a horizontal force of 10 Newton. Clear? It is possible only because of friction is there, or friction should be there between the block and the wall. There is friction. It is given mu is equal to 0.2 given in the question. Okay, here the weight of the block is, what is the weight of the block? See, actually what are the forces acting on the block? One is mg, the gravitational force acting downward. Okay, and which force agent is balancing this mg? The agent of force which balancing this mg is frictional force here. Frictional force is here, F, isn't it? So this is in equilibrium. This is in equilibrium. It is both in vertical and horizontal equilibrium. This horizontal 10 Newton force is balanced by which force? That is balanced by this normal reaction. Normal reaction, isn't it? So this is horizontally in equilibrium means the normal reaction value is equal to 10 Newton. We understood? Okay, and it is in vertical equilibrium means this mg is equal to frictional force. Okay, the magnitude of this mg and the frictional force are equal. That's why it is in equilibrium. Right. Now what is the frictional force? Is mu into normal reaction. Frictional force is mu into normal reaction. Mu is given 0.2 and normal reaction is here 10 Newton obtained. That pushing force is equally obtained as the normal reaction from the wall. Okay, 0.2 into 10 is 2 is the answer. So the weight of the block is 2 Newton. It is option 4. Okay, that's very simple question. So the idea of friction is there. The idea of equilibrium also used there. Okay, the next one. Two fixed frictionless surface inclined plane making an angle 30 degree and 60 degree with vertical as shown in figure. Here you can see that. 30 degree and 60 degree with vertical. Okay, here it is 30 degree means here it is 60 degree with vertical here in the question here with vertical here is 30 degree means here it is 60 degree given in the figure, and here it is 60 degree means here it is 30 degree. Okay, fine, no problem. Now two blocks A and B are placed on the two planes. Okay, what is the relative vertical acceleration of A with respect to B? Consider this inclined plane. Here is an inclination theta. Okay, now there is a block here, this block of mass M. Okay, now the acceleration experienced down the plane is, g sine theta. Okay, now we can split this g sine theta into two components, one along horizontal. If this angle is theta here, this angle is also theta. Okay, now what about this component is g sine theta into cos theta. Okay, g sine theta into cos theta. And what about this vertical component is g sine theta into sine theta. G sine theta into sine theta means g sine square theta. This is the vertical acceleration of each block. Okay, so what is the relative vertical acceleration? The relative vertical acceleration is g, then sine square 60 in this case minus sine square 30 in the second case. Okay, relative, I can write a relative. Okay, relative vertical acceleration, g sine square 60 minus g sine square 30. Okay, yes. G is here, the options are 4.9, 9.8, etc. So we are taking this as 9.8. Sine square 60 is 3 by 2 minus. Okay, what is sine 60 is root 3 by 2. Root 3 by 2, so it is 3 by 4 there. Okay, 3 by 4. 3 sine square 60 is 3 by 4. Okay, minus sine square 30. Sine square 30 is 1 by 4. Okay, sine 30 is 1 by 2, its square is 1 by 4. Okay, 3 by 4 minus 1 by 4 is 2 by 4. 2 by 4 is 1 by 2. 1 by 2. So 9.8 into 1 by 2 is half of 9.8. Half of 9.8 is 4.9 meter per second square in horizontal direction. It is incorrect. Okay, it is not in horizontal direction actually. It is not in horizontal. 9.8, this is also incorrect. 0 is incorrect. 4.9 meter per second square in vertical direction. That's the answer of this particular question. Okay, option 4. You understood this? Okay. Now, next question is this one. Force required to move a mass of 1 kilogram at rest on a horizontal rough plane. Consider a horizontal rough plane and you imagine a block of 1 kg there. Okay. How much force is required for this block to start its motion? Here, this friction coefficient is given here as 0.1 unitless quantity and G is 9.8. G is 9.8 we have to take. Okay. The question asked is how much force is necessary for this block to start its motion, which means we are applying a force. This force should overcome this frictional force. Okay, maximum limit of frictional force. Okay, what is the maximum limit of frictional force is Fs max. Okay, means we have to apply a force which should overcome this Fs max. Okay, so the answer here is F is equal to Fs max. Okay, and what is Fs max is mu into or mu s into normal reaction. Okay, mu s into normal reaction. So what is mu s value given here? 0.1 and normal reaction is mg. Normal reaction is m into g. M into g. Okay, so it is equal to 0.98 is the answer, isn't it? 0.98. Okay, 0.1 into 9.8, 0.98 is the answer. Option 1 is the correct answer. Okay, yes. Then the next question is a block is kept on a frictionless inclined surface. Okay, a block is kept on a frictionless inclined surface with angle of inclination theta. Inclined surface. The incline is given an acceleration a to keep the block stationary. Then what is the value of a? Consider an inclined surface of inclination theta. Fine. Here is a block is placed here on this inclined plane. Okay. Now, in order to keep this block stationary there, we can accelerate this inclined plane. Okay, we can accelerate this inclined plane such that this block is stationary. Then what is the value of this acceleration is asked. Okay, I think you understood the question. Now, what are the forces acting on it is? One force is acting mg downward. Okay, and the other force is acting normal reaction n perpendicular to the surface. Okay, now you take the components of this normal reaction here. You can see what about this angle is also theta. See, you can see this angle is also theta. If this angle is theta here, this is theta, 90 minus theta, theta. So this one is n cos theta and this one is n sin theta. We have splitted this n into components. Right. Now, this system is in acceleration, means this block is in an accelerator frame. Okay, the block is in an accelerator frame means what we can assume a force on the block which is called a pseudo force. Okay, pseudo force you studied. What the pseudo force is? The force we assign for a body which is placed in the accelerating frame. This inclined plane is in acceleration, so the body is in accelerated frame. So what is the pseudo force? The pseudo force equation is pseudo force Fs is equal to mass of the body into acceleration of the system and with a negative sign. Okay, what is pseudo force on a body? Mass of the body into acceleration of the system with a negative sign. Okay, what is the negative sign? Indicates that the pseudo force is acting in the opposite direction of the acceleration of the frame. So this is Fs. This is Fs. Okay, now you look into this figure. The block is stationary there. The block stationary there means the net force cancelled. Net force cancelled means in the horizontal equilibrium we say n sin theta n sine theta is balanced by this pseudo force Fs. Pseudo force Fs. Okay, and what's the magnitude of this Fs is ma. Okay, you understood. Why we are not writing here minus? We considered that minus already by plotting this force into in the opposite direction of acceleration. Okay, what is the pseudo force is opposite to acceleration, and this magnitude is ma. Okay, so this pseudo force I am writing it is ma. That's fine, it is ma, right? And you consider this vertical equilibrium, we can write that this n cos theta is equal to what? N cos theta is equal to mg, isn't it? Now dividing these two, we get tan theta is equal to a by g. Tan theta is equal to what? A by g. So what is A is equal to g tan theta. I think you understood this properly. The concept of pseudo force is the mass of the body into negative of acceleration of the frame. Okay, so the answer is g tan theta, which is option 4. Okay, Kavish. Okay, so many of you are commenting this. Very good, keep commenting there. Okay, keep doing there. Okay, this answer is option 4, and the concept of pseudo force is an important concept here in the laws of motion. You practice some more questions there with the pseudo force. Okay, fine. Then the next one, the last one is, in the arrangement shown in figure, the strings are light and inextensible. There are two strings here, 1, 2, 3. There are light string or massless. You consider massless strings and inextensible. The surface over which the blocks are placed is smooth. Means the surface is smooth means no need of considering friction. Okay. What is the acceleration of each block? Acceleration of each block means will be same, because this is a connected system. Acceleration will be same for all the blocks. Okay. And what is the acceleration is, the formula is the net force or the external net force applied divided by total mass. Very direct formula, because this is Newton's second law. What is the net force? The net external force is this 28. Net external force, that 28 divided by total mass, 4 plus 2 plus 1, 7. Okay, so what this is, 4 meter per second square. This problem is also from the connected system problem. It is 4 meter per second square. Okay, many of you are commenting your answers, and some are putting the thumb, and okay, everything fire is there. Okay, so students, you please continue your good work there. Okay, in the next day we will be meeting with the next chapter. Thank you. Good night.
Hi dears, welcome back to Master NEET live DPP session of chemistry. So let's start with the question from the chapter thermodynamics. Are you ready? So these are the questions, guys. These are the questions. Enthalpy change for a reaction does not depend on enthalpy change. Okay, listen to me carefully, guys. Enthalpy change is delta H. It does not depends on. That's the question. What about the first one? The physical states of reactants and products. Yes, of course. If it is liquid, if it is gas, if it is solid, according to the state, this enthalpy will change. Enthalpy will change. It's a factor. What about the second one? Use of different reactants for the same product. Of course, whenever reactants or product will change means enthalpy will change. And what about the next one? The nature of intermediate reaction step. That's the answer. That's the answer. Why? Why? Because enthalpy change depends only on the initial and final state. If there is a reaction from A to B, so this is the initial step, this is the final step. It does not, this delta H does not depends on how it is going on, because from the initial as well as the final only this delta H will depends. So they are telling the nature of intermediate reaction step. No, it is a state function. I hope you got it. Ready guys? Yes or no? Yes, 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 Shiny Shabu. Yes, Kavya Shah. Yes, that's the answer. That's the Magashri. Yes, correct. Exactly. Then the difference in initial and final temperature. Of course, temperature is changing, enthalpy will change. That idea is important. Okay, the difference in initial and final temperatures and what that also depends. Enthalpy change is depending. Okay, that is depending. That rule is actually whenever temperature is changing, enthalpy is changing. That rule is called Kirchhoff's law. Kirchhoff's law. Okay, at different temperatures, at temperature T1, enthalpy changes delta H1 for the same reaction. Temperature T2, enthalpy changes delta H2, then their enthalpy change and temperature is related as delta H2 minus delta H1 divided by T2 minus T1 equal to delta of Cp. That relation is called Kirchhoff's law. Okay, Kirchhoff's law in chemistry. Okay, thermodynamics. I hope we discussed that idea in the class. I hope so. Okay, guys. Okay, if it's so, then we can move to the next question, guys. This is the next question. It's a simple one, humble one. In an endothermic reaction, the value of change in enthalpy, delta H value for endothermic, it is positive. Exothermic, it is negative. Thermoneutral reaction, it is 0. Okay, so we can move to the next one. Easy one. Enthalpy of formation of two compounds X and Y are. There is one compound X, its enthalpy of formation delta H of 0 is given as minus 84 kilojoule, and that of Y how much? Minus delta H of 0 equal to minus 156 kilojoule per mole. Then which of the following statement is correct? Which has more enthalpy of formation? This Y. What's the meaning? Whenever Y is forming, they are releasing 156 kilojoule. Automatically they are releasing means its energy is decreasing, stability increasing. So that means you have to remember, whenever any species they are releasing more energy means they are highly stable. They are highly stable. So Y is more stable than X. That's the answer. Y is more stable than X. This minus represent releasing. So they are releasing more. So Y is more stable. Here they are telling X is more stable than Y. X is less stable than Y. Yes, Y is more stable, or else X is less stable than Y. Isn't it? Simple. Okay, guys. Yes, Kavyasha. Yes, correct. Okay, once you are getting the answers means you have to put the fire. Burn the comment box. Come on, everybody. Yes. Okay, we can move to the next question. Change in internal energy. They are asking you to find out the change in internal energy. Change in energy calculation formula is delta U. That is actually first law of thermodynamics. Delta U equal to Q plus W. This is the mathematical representation of what? First law of thermodynamics. Okay, delta U equal to Q plus W. And here they are telling when 4 kilojoule of work is done on the system. So we must have to remember, whenever for our system, if anything is a profit for our system, then we have to consider it as a positive, and if it is a loss for the system, we have to consider it as a negative. They are telling work done on the system. Work done on the system means some energy is giving to the system. That is how much? 4 kilojoule. 4 kilojoule plus. Okay, and 1 kilojoule of heat is given out by the system. So from the system some 1 kilojoule is missing. That means heat is actually losing. So that's why it is minus 1 kilojoule. So Q plus W, how much it is coming? 4 minus 1. So that's equal to 3 kilojoule per mole. So that means option 4 is the correct one. Okay, guys, I hope you got it. Yes, option 4. Yes. 3 kilojoule is the correct answer. Okay, if it's so, then we can move to the next one, guys. This is the next question. The work done during the expansion of a gas from a volume of 4 decimeter cube to 6 decimeter cube. against a constant external pressure. That's the important thing. Whenever you are seeing constant external pressure means that is actually work irreversible. Work irreversible. Constant external pressure means that should be work irreversible. How we can find out the work irreversible? Minus P external into delta V. What's the formula? Minus P external into delta V. What's the minus P external? How much they given? Minus P external is 3 atm. So minus 3 atm into what is delta V? Delta V is 4 decimeter cube, change it to 6 decimeter cube. So change is 2 decimeter cube, okay, 2 decimeter cube. Final minus 6 minus 4 means 2. So 2 into 3 means minus 6 atm decimeter cube, decimeter cube. We know that decimeter cube equal to nothing, that's liter. That is liter. So I can write minus 6 liter atm. Minus 6 liter atm. I taught you in the class, I hope you remember, 1 liter atm equal to 101.3 joule. 101.3 joule. Here you can see 6 liter atm, every options are in joule. So I have to multiply minus 6 into 101.3. It is approximately how much I will get? Minus 608 joule. Option 2 is the correct one. I hope you got it, guys. Yes, Kavya Shah, yes, Magashri, yes, correct, okay. So we can move to the next question, guys. This is the next question. What about this question? The enthalpy change for the reaction. This is the reaction they given. N2 plus 3H2 gives 2NH3. Okay, gives 2NH3. Its enthalpy change they given. How much they given? Delta H equal to minus 92.38. They are asking what is the internal energy change? Delta U how much? That's the question. How I can relate delta H and delta U? Delta H equal to delta U plus delta NGRT. This is the formula we have to apply. We have to use. So they are asking to find out delta U. So what is delta U? Delta U equal to delta H minus delta NGRT. What is delta H? Delta H is minus 92.38 kilojoule. All are in kilojoule. All options are in kilojoule. So I am going to take everything in kilojoule. Okay. So minus 92.38 minus. What is delta Ng? Delta Ng means number of moles of gaseous product minus number of moles of gaseous reactant. Gas only we have to consider. So here how many gases are there? 2. Here how many gases are there? 4. So 2 minus 4 minus 2. So minus 2 into R. R value is 8.314. 8.314 joule Kelvin inverse mole inverse. But here we are talking everything in kilojoule. So how I can convert this one into kilojoule? 8.314 divided by 1000. So I am writing 8.314 divided by 1000 into temperature is 298 Kelvin. 298 Kelvin. So while I am doing this one, I can do like what? I can do like what? Like this. Okay, minus 92.298 is coming. So what's the value? So that's equal to minus 92.38. This become plus 2 into 8.314 divided by 1000 into 298 you can do. Once you are solving from minus 92.38, this is somewhat 4 point something will come, that you are subtracting, means you will get the answer. Second option will get minus 87.42 kilojoule you will get. I hope you got the answer, guys. Yes, Kavisha, yes, correct, yes, Makashri, yes, Shiny Shabu, yes, the correct answer. They are commenting while I am seeing the answers in the comment box. I am feeling happy. Okay, so we can move to the next one, guys. This is the question, is another simple question, easy question. For the reaction, they gave one reaction. For that, what is the delta H minus delta E? Delta H minus delta E is nothing. That is equal to delta NGRT. Delta Ng means what? Number of moles of gaseous product minus number of moles of gaseous reactant. What's the number of moles of gaseous product? How many gaseous products are there? 3. How many gas reactants are there? Here 5, here 1. Total 6. 5 plus 1, 6. So that means delta Ng means 3 minus 6. 3 minus 6 into RT. R into T. That means minus 3 RT. So minus 3 RT means option 3 is the correct one. I hope it is very easy one. Okay. If it's so, then we can move to the next question, guys. This is again another the same question, same kind of question. Value for delta H minus delta E for the following reaction, 27 degrees Celsius will be. Okay, 2NH3 gives 2N2 plus 3H2. This is the equation. 2NH3 gas gives N2 plus 3H2. N2 plus 3H2 gas. Okay, so they are asking again delta H minus delta E. Delta H minus delta E equal to delta NGRT. What's the number of moles of gaseous product minus number of moles of gaseous reactant? Here it is 1 plus 3, 4. Product is 4 and reactant is 2. So 4 minus 2, 2. 2 into R. R is 8.314 into temperature is how much? Temperature 27 degrees Celsius means 300 Kelvin. So that's it. 2 into 8.314 into 300. So which option will come? Fourth option will come. I hope it is okay, guys. Fourth option, yes, fourth option, not the third option, fourth option will come. Okay, fourth option, it is 2, you just reverse that one. Delta Ng means number of moles of gaseous product minus number of moles of gaseous reactant. Okay, yes, we can move to the next question. This is the next question. Which of the following delta E equal to delta H? We know the equation, delta H equal to delta E plus delta NGRT. When this both will be equal, at delta Ng equal to 0, delta H equal to delta E. So we can look it. In which case delta Ng 0. Here you look it. Here 2 gaseous product, 1 gaseous reactant. So in first case delta Ng equal to 1. What about the second case? Here 2 gas, here 3 gas. So 2 minus 3 minus 1 will be coming. So that's not the answer. Again, while we are looking, this is minus 1 is coming. Okay, here minus 1 is coming. What about here? 2 gas in the right hand side, 2 gas in the right hand side, 2 gas in the left hand side. So here delta Ng equal to 0. Option 3 is the correct one. Here also not like that. Here it is delta Ng equal to here there is no gas, 0 gas, here half gas, here 1 gas. So minus 3 by 2. So option is which option? Third option. I hope it is okay, guys. Okay, ready? And the next question, for the reaction PCl5 gas gives PCl3 plus Cl2. Here while you are looking the delta Ng equal to here 1 plus 1, 2. 2 minus 1, that is 1. Delta Ng is positive. Means obviously delta H equal to delta U plus this 1 into RT. That means you will get delta H once you are adding RT plus delta U. That means delta H will be always greater than delta U. Delta U is nothing. Delta U is delta E only. Okay, delta U is delta E only. So delta H will be greater than delta E. Option 2 is the correct one. So that's all about the 10 questions we already gave as an examination point of view. That's all, guys. Easy area only we discussed the question today. Tomorrow we will discuss some more difficult question from the thermodynamics. I hope you guys are watching the videos with that much confidence and all. You have to keep the same confidence and we have to make it. Okay, within this 45 days we have to get the very good mark in the NEET examination point of view, and we have to get admission in a very good medical college. Okay, so don't forget it. Today biology session won't be there, so we will meet you on tomorrow. Up to that, thank you.